key trends, emerging technologies, and addressing the skill gap in the semiconductor industry. So first of all, I would like to thank the management for permitting us to organize this event. And now I would like to extend my heartfelt welcome to our chief guest, Mr. Vinod Kumar Gopinath, who is the Chief Technology Officer of Advian Technologies, to this CHIP Confluence. Thank you very much, sir, for accepting our invitation and being present here. So with his vast experience, our chief guest will deliver an address on the topic Emerging Trends in Semiconductor Design and Architecture. I would like to warmly welcome our guest of honor, Mr. Gershon Samuel, Principal Engineer, Microchip Technologies. Thank you, sir, for being present here. We welcome you on behalf of the institution and the department. So through his contributions to the technology and innovation in various industries, our guest of honor will deliver his address on the topic Exploring the World of Chip Design from RTL to GDS2. So after that, we have a panel discussion on the topic Addressing the Skill Gap in the Semiconductor Industry, which is moderated by Dr. K. Swaminathan, founder and CEO of Silsic Innova Technologies Private Limited. And our four panelists, Mr. Hariharan V.S., Vice President HR from Advian Technologies, Mr. Karthik Nagappan, Vice President Engineering from Dassault Semiconductor, Mr. Sriram Tangarasu, Senior Branding Specialist in Mobivay, and Mr. Vignesh Ramodaran, who is a Senior Verification Engineer from Qualcomm. I extend a warm welcome on behalf of our institution and our department to each one of them. Now I warmly welcome our strong pillar of support, our Dean Sir, to this CHIP Confluence. Welcome, sir. And I also feel glad to welcome our Vice Principal Academics, who is always supportive in all our department events. Welcome, ma'am. And I welcome all the Vice Principals and HODs of other departments, faculty members, research scholars, and students for this CHIP Confluence. And now this event is made possible only because of the tireless efforts of the faculty coordinators and coordinators of IEEE School Chapter. My hearty wishes to each one of them. I would like to thank the other departments and the maintenance team for their support in organizing this event. And last but not the least, I welcome all the participants from other colleges. Once again, a warm welcome to this CHIP Conference. May our time together be both enlightening and enriching. Thank you.
Thank you, ma'am, for your warm and cheerful welcome. In the esteemed corridors of learning, her presence is a radiant force of intellect and poise, charting the course towards academic distinction. Her unwavering resolve nurtures a culture of scholastic triumph, empowering learners to unlock their full potential. We speak, of course, of our distinguished personality, Dr. C. Gomati ma'am, Vice Principal Academics and Placements. It is with immense joy that we extend our invitation to her to share her profound insights and wisdom in the special address.
Thank you. And once again, I join the team in welcoming all of you for this CHIP Confluence. And very nicely coined the term as a confluence, where we are going to discuss about the newer trends which are happening in the semiconductor industry. And as we all know, many of you who have actually gathered here are the students who are doing your course in electronics, or you are the researchers who are in the field of electronics, and even the other people and faculties and HODs who are actually have joined this particular program. Now that we all know that understanding the kind of chip technology is inseparable from any other part of a branch of engineering. So as we have been talking with our guest and all, so the guest himself being from computer science, he was saying like how computer science and the programming skills will be helping in developing the verification process of the chip and other things and all. So we will get to know more from the stalwarts who are sitting on dais, the Chief Technology Officer, Mr. Vinod from Avion, and Jesham Stanway from Microchip Technologies. So now that we all know, recently we have even witnessed the launching of semiconductor industry by our own Prime Minister, and this is all for us to know what is actually happening around us, that India, how we are actually welcoming the semiconductor industry. So as electronics students, we have to know what is going around and what are the opportunities for us. So generally, as a quote says about our various branches of engineering, people say like computers, knowledge about the computers. Computers are mainly the head of any human being. Actually, that is a head. They proudly say that there is a head. Then what is actually when the stalwarts in semiconductors they talk about, or the chips, they say that that is actually the brain of the head. Without this chip, now that you would see that in papers you might be reading anything for that matter. We know very well the one thing which actually has gone inseparable from the human body is our mobile. Even while sleeping also we are keeping aside that everyone could see what kind of advancement has happened in the mobile, that we have actually moved from, again I used to tell my students that we have moved from the era of Nokia 1100, which used to be weighing at least nearer to 1 kg or so. People even used to hang around the neck also, now that the advancements has gone into the semiconductor technology and the advancements in the chip manufacturing and all that, is that people go with how to go with a miniaturized version, how to reduce the size, how to reduce the space occupied by the chip. So researchers are keep on happening in those kind of field as well. We are also looking on how to concentrate on the power consumption, right? So we can't just afford to our mobile or anything losing its power just within half an hour or so, right? So now that the researches are happening, in spite of having so many apps running in background, we still want to hold that power. So for power consumption, so many kinds of researches are happening. So with all these advancements happening in semiconductor industry, it is the right time that we as electronics engineers, we got to know about from the, and we also have to hear from the stalwarts, like what is actually really happening in the semiconductor industry. And as I told you, leave alone this mobiles, which we are very much aware of. Even for that matter, if you are taking, for example, the automotive electronics or the automobile, we see that the electronics is part and parcel of anything for that matter, right? And now we have few buzzwords, as we all are aware of, artificial intelligence, and people even talk about machine learning and IoT, and also we combine our own 5G, now we are moving on to 6G also, right? So all these advancements which are happening, which actually has created some kind of advancements even in the semiconductor industry. So once again, on behalf of the team and the staff and the students of this campus, I welcome the guests of the day, Mr. Vinod and Mr. Janam. And I am also, like all the other people in the auditorium, I am also eager to hear from the stalwarts. Welcome you all once again for this chip conference. Thank you.
Thank you, ma'am, for your words of information about the semiconductor industry. A man of unwavering determination and boundless willpower, he stands as a guiding force, fostering a culture of collaboration and teamwork among building talents. Yes, we speak none other than our esteemed personality, Dr. C.V. Jayakumar, Dean, Faculty of Engineering and Technology, SRMIST Vadapalli campus. With immense pride, we now extend our heartfelt invitation to him to grace us with his presence and deliver the special address.
Good morning. Great. It was my great pleasure in joining myself with my previous speakers in saying a hearty welcome to the chief guests who were kind enough to accept the invitation to be amidst us of this wonderful Confluence. The theme is so chosen in the right way that unlocking the potential of semiconductors. When I don't know how many of you have seen a big radio type of things in your granny's house. We need a radio, sir. The first question, right? Okay. So probably I don't know whether the cheapest or the name have seen it. The moment we switched on, there will be a green eye blinking, searching for the station or something like that, referred to the magic eye. And that was the electronic device which we saw when we were kids. How old, don't ask me. Then slowly, it was a valve type radios. Then slowly came a change and then transistors were discovered or invented, and then the size of the radio box or the radio OT, which we call in general, has been reduced to a kind of a rectangular box. And the miniaturization, a small type transistor, a carry transistor, which will be of this size and as thickness is this much. And every time a cricket match goes on, most of the guys who were my classmates used to carry this down on the book bag, right? So this will always be there in the hands, and அந்த பிள்ளையோட ஃபீலிங் அப்பா நம்ம பிரின்சிபால் பண்ணி சார் நம்ம டீனும் அந்த பேட்சில் உள்ளவங்க இப்போ நம்ம இனிமேல் மொபைல் கொண்டு போகலாம் கிளாஸுக்கு தப்பு கிடையாது. ஸோ அதை வச்சுட்டே தான் நான் அதுக்குள்ளே வச்சுட்டேன். I was not interested in cricket then, even now, that's the difference. Slowly, the technological development has taken us to the level what BP was touching upon. It was all a miniaturization. From this size to this size to this size to palm size. Now, what is the minimalist size of the device which uses whatever, which is used for anything and everything you think of? Smartwatch. You have it on your hand. You get your calls, you get your messages, you get your health and digital monitor. How was it all possible? Because it's not that it is one domain, multi-domain development. Right? So miniaturization, and now the buzzword, the talk of the minute is the semiconductor. VLSI semiconductor, large scale integration to very large scale integration, then tremendous. How many of you really feel that, honestly? He's here to a branch of the club. A feeling? Nobody has a feeling? Okay, I'll put the question the other way around. How many of you feel proud that I chose easy? That's good. So others, can I take it the other way around? I'll answer the first question. It is no more in mechanical engineering or electronics engineering or computer science. No. It's called just engineering, that's it. Where you should know everything. So you got to upskill in all the domains, be it semiconductor, be it electronics, or be it communication. What I mean by communication, the electronics communication, not the other way. Of course, the overall or verbal communication comes into play also. Right? And what is the yet another buzzword you come across every day? Come on. I want to learn something from you guys. Okay, I'll rephrase the question. If your teacher asks you to submit an assignment on some topic, X, Y, Z, what do you do generally? bit louder. I have a problem with my ear. I am a bit hearing impaired person, say. Any language. I do have other students. I want other students to interact as well. No hard feelings, everything. No hard feelings. Come on.
So copy from internet.
Super. A big round of applause. He has agreed that he has copied from somewhere. How many assignments you have submitted that way? I don't know the name now. Infinity. Any teacher gives any assignment, I just go Google something. Google and all is gone now, right? To a larger extent. What is that? ChatGPT. What is the basis for that? AI. And what is the advanced version? I had something initial or a prefix for AI. Something. His answer is wrong, doesn't matter. I don't know everything. And I don't expect my students also to be correct in all the things. Honestly. Gen So, there are things to reduce your burden, but still increases your burden. In the sense, you will not be bothered to think about it. Why should I? That applies to me as well. If I want to apply somewhere and write my resume, I can say I want to AI or hello AI friend or whatever you call it, or BD or something like BAI, Bing. I want my resume. Then it might ask questions. I will do something. It might give me a wonderful resume than what I myself could imagine. It's about that level. But underneath this, can we, as a human being, be eliminated absolutely? Don't we need a human being for anything and everything? How does the AI work? How does your ChatGPT work? On its own? Give me some answer. Specs with a beard, yes.
Learns from
A bit more louder, please.
learns from other people's work.
Other people's work? That's all.
It scraps other people's work and tries to combine it.
Combined. So somebody is teaching the machine. Who is that? It's again human. So human forces cannot be eliminated at any point of time, how much more the technology grows. As the technology grows exponentially, the human thinking power or the relative thinking power should also grow in a more better exponentially way. Only then we'll be able to feed this machine so that it works efficiently and effectively. So my humble request to my student friends is that you try to grow with the technology at a faster rate. If the technology grows at an X rate per day, you should grow at 2x rate per day at least, so that you will be able to stand aloof or unique and then survive. Ultimately, the survival of the system is comes to question. So let's equip ourselves with the current trends and abreast of the recent developments. It's not an advice, definitely. It is the need of the hour. And more especially Gen Z. Madam சொன்ன மாதிரி இது இல்லைன்னா நான் இல்லை அப்படி இல்லை ஒரு நாள் actually on a trial basis keep it aside, see whether we will live the next day, we will be living in a more healthy way than the previous day, obviously, because the rays that come to this doesn't hit me, doesn't affect me much. So I'll be a class of communication. So what? Somebody will give us the information. மச்சான் அன்னைக்கு அந்த கிளாஸ் இப்படி போச்சு டேய் நீ வந்தாண்டி அவன் அறுத்துட்டான். So the information will reach you even without the device on your hands. Correct? And நம்ம சத்தியமா வந்து வேர்ல்டுல என்ன நடக்குது அது நடக்குதுன்னா சத்தியமா இதெல்லாம் தெரிஞ்சுக்க போறது இல்லை. Correct? Correct me if I'm wrong. Of course, any generalized statement will have always an exception. I would accept it. நம்மளை சுத்தி நம்ம மெயினாக எதில் கான்சன்ட்ரேட் பண்ணுறோம் சார்? give me 2 moments. Where do we concentrate much? என்ன சோஷியல் மீடியா உட்காந்துருக்கீங்க சொல்லுங்களேன். ஓ ஆனஸ்டா ஃபர்ஸ்ட்டாக பதில் வேண்டாம் எனக்கு ஏதாவது நல்லது கற்றுக்க முடியும்னா ஐ கேன் ஆல்சோ கோ இன்டு தட். ஐ தான் கேட்குறேன், வேற ஒன்றும் இல்லை. என்னதான் மிஞ்சி போனால் இன்ஸ்டா ரீல் பார்ப்போம், இல்லைன்னா எக்ஸில் ஏதாவது ட்விட்டரில் பழைய ட்விட்டரில் ஏதாவது எப்படிலாம் ஒருத்தன் எந்த அளவுக்கு நல்ல விதமாக திட்ட முடியுமோ திட்டத்தை பேசிக்கிட்டு கேட்டுக்கிறோம். அவ்வளோதான். நாங்களும் அதை எங்களை கூட திட்டிக்கிறதுக்கு யூஸ் பண்ணிக்கிறோம். வேற இவர் என்னமோ ஒன்றுமே தெரியாதுன்னா நம்மகிட்ட கேள்வி கேட்கறது, எல்லாம் தெரிஞ்சு வச்சிருக்காங்க சார், தெரியாத மாதிரியே நம்மகிட்ட கேட்கறது. So friends, you need diversion, you need relaxation. That's what the life is all about. So compete with one another, try to learn as much as you can. Or so go to hear much about the chip technology and the semiconductor industry. How big it's growing now with these stalwarts. I don't want to take much, but I know I've taken. So wish each and every one of you a wonderful learning day and wish you all the very best. Thank you. God bless you all.
Thank you, sir, for your valuable insights on recent technologies. Now, it's time for felicitation. I now request our Dean Sir, Dr. C.B. Jayakumar, to felicitate the Chief Guest, Mr. Vinod Kumar Gopinath, with a memento and an lunchbox. Thank you, sir. I now request our VP Ma'am, Dr. C. Gomanti, and our HOD Ma'am, Dr. A. Shirley Edward, to felicitate the guest of honor, Mr. Jeshwant Samuel, with a memento and an lunchbox.
Thank you, dignitaries. It's now time to introduce our chief guest, a multi-talented professional whose career has been a testament to versatility, innovation, and continuous learning. He did his UG BSc Physics at Loyola College, Chennai, and Master of Engineering in Computer Science at Indian Institute of Science. His journey began with IBM in 1995, where he swiftly transitioned from a software engineer to a project manager. In 2004, he embraced the dynamic startup culture at Novatium Solutions, eventually ascending to the role of Chief Technology Officer. His passion for education led him to the school KFI in 2017, where he not only imparted knowledge in physics but also played a pivotal role in school administration and adapting to remote learning during the pandemic. Since 2018, his expertise has flourished in digital verification, notably as Chief Technology Officer at Edbeyond Technologies, where he excels in developing test plans, architecting test benches, and overseeing the verifications of intricate systems. With a rich tapestry of experiences across technology, education, and innovation, he optimizes the spirit of adaptability, leadership, and relentless pursuit of excellence. Now, I take immense pleasure in inviting our honorable chief guest, Mr. Vinod Kumar Gopinath, to deliver the TED Talk on the topic Emerging Trends in Semiconductor Design and Architecture.
Good morning. Yeah, so I'm very happy to be a part of SRM Confluence, and I thank the SRM Institute to have called me and given me about 45 minutes to talk to you about emerging trends in semiconductor design and architecture. So you won't hear a lot. It's not a big list that I'm going to give you here. I'm just going to talk about two trends. I'll spend some time in talking about these trends, so we get to know, I mean I got to know too when I was going through this, as to why do we need trends, why do we need new architectures, why do we need new designs. So we spend some time on it. Okay. For this, I go back to the future. Design of new chips, new architectures that happen in the chips, birth of new chips are always driven by the market need. Right? It's not that someone decided that I have lots of time, I don't know what to do, let's make a new chip. Yeah, it happens sometimes maybe. Right? But there is a market need which always drives it. Right? Because it's a very expensive process and it's got a lot of risk. Like, people are going to spend money, and so you have to be sure why you're doing it. Right? So there's a market need which drives it. Usually that means that there's some kind of business at the end of it, there's some kind of money to be made. So if you look at what happens, in the 1980s, we had the GPU or the CPUs that came up. The x86, somewhere it took birth in 1980s, 85, 86 time frame. Why? Because computers started getting into our homes. Like before that, computers used to fill up rooms, one full room, and you couldn't have it in your homes. But as the transistors came by and the size of the transistors reduced, you could think of getting computers into homes. And at some point of time, in the 80s, our schools and homes and offices started getting computers. And that's when your general purpose processors were birthed. Now, once the general purpose processors came by, so the developments happened, and audio video materials, content started getting stored in these devices, and also these devices were used to see these materials. Right? Now, when that happened, is in the 90s primarily, these general purpose processors were not very good at decoding material or encoding material. It took time. It was not designed for taking care of audio video materials. So then, what happened was that we started having application-specific integrated circuits, or ASIC, which means that there's one IC that only took care of graphic processing, there's another one which only took care of network processing, another one which only took care of video processing, audio processing, and so on. So you started getting application-specific ICs, and companies like Compaq and so on, like built PCs with different chips being placed on them, on the motherboards, and that's a development side. So the need, again, is the digitalization of audio video material, which resulted in ASIC. Right? Now, what happened in the 2000s? In the 2000s, we saw, as I was saying, the birth of mobile communication. We got mobile phones or cell phones, and so you had network reaching everywhere. You could access a network, you could get data, you could get computing anywhere. That started taking birth, and that's where we started getting smartphones. We started carrying computing devices in our pocket. Now it's very common, but this started towards the second half of the 2000s, the first decade of 2000. That's where it started. Smartphones take that impact. Now, this meant that I want to do a lot of things which I do with the computer, like watch movies, take photographs, access the internet, stream data, stream videos, and so on, but it has to be done on a small device, which I can carry in my pocket, and it should be able to run for a long time. It can't be so much that I need to keep charging it from time to time, which meant that it needs to be thin, small, and efficient, power efficient. Again, this was touched upon by man, right? So what happened there is that now you've gone from one processor to a set of processors which occupy a lot of space. I can't put all these processors in a small device like my mobile phone. So what I do is I take all these chips, put it together in a single chip, and I call that single chip a system on a chip or an SoC. And that's where the SoC is. So me it is, I want to move around. I don't want to consume too much of energy. I want the device to move around. It should be small enough to do that. And I don't want it to consume too much of energy. So I created a system on a chip. And in 2000, what happened was IoT. And computing became everywhere. It started coming everywhere. There were devices which are capturing data, they had to be sent, and each of it was a small computer in some particular manner. So we had lots of computers everywhere, which is small enough and again thin enough to do some amount of processing. More importantly, which I don't mention there, is that there's a lot of data which came by. Right? That's why the 2000s, especially the second half of 2000s, is where the term big data took hold. Right? We started hearing a lot more about big data because we had so much of data, and the data, when you churn it, you can get information. Right? So we have data and information. We're not looking at data. When we look at data, we don't understand things, but when we churn the data, we're able to get information. That information we can use. And I don't want a system which is going to take ages to come up with the information. I want it to be quick. And again, I can't occupy floors and floors of computers. I can't have so much of computers to churn the data. So again, I wanted the whole SoC to be more efficient. So all along, right from the 60s, the size of the chips were reducing. Right, size of the transistors were reducing, and hence the chip was reducing. Now we reach a stage where you are in the 9 nanometer, the 7 nanometer. I mean, that's so small. You're now reaching the stage where it is similar to the size of an atom. Right, the nanometer is the size of an atom. So how much thinner can it get? How much smaller can a transistor get? So this is the big thing which happened. Things started thinning down. Can you do things more efficiently? Right? And now, the big thing, I think every speaker out here said those two alphabets, right? A and I. So that two alphabets is there everywhere. It's almost become a cliche to talk about AI. Everyone talks about AI. But the reality is that today AI has become big. We see a lot of scope with AI, though in an education institution it can be a headache, right? In the sense, how much do you know and how much have you taken the help of AI is something which, as educators, when I was an educator too, we were not able to differentiate. Right? So the intent is not that you give a response, the intent is to find out how much do you know and find out the gap. That in AI becomes a headache of sorts. But AI is very useful in a lot of places. It's been used for a number of years. These words that you see here, which is a written system that can think rationally and think the systems that can act rationally. These are not some things which are framed in the last 2 years. They've been there from the 60s itself. Right? So AI has been around for many years. In the 90s, when I was doing a master's, I took courses. One is in neural networks, others in AI. And when I learned 30 years back, and when I look back at what I learned, it doesn't seem too different. It's become more complex, agreed, but it doesn't look very different. Right? So those are the two concepts, and underlying these two concepts, you have the concept of learning. So what AI is all about is learning. You want a system to make something intelligent, as in that intelligent computer program. Yeah, the program has to learn. Right? We don't just say, think of the hundreds of possibilities, put everything on the code, and that works. That's not the intent. Can the program learn? How do you make something learn? So that's the thing which is there. So the question which is here is that, is the spread of AI resulting in an in the evolution of chip design? Is there some kind of change that needs to be done in chip design? The answer is, if it is a no, then I wouldn't be here talking about it. The answer is yes, and sorry. The answer is yes, and that's the reason why we are talking about it. Okay. And all the, I mean, AI has been, as I said, AI has been there for a long time. The Google Matrix came out in the first decade of 2000s. They talked a lot about AI, but I think the recent discussions about AI are happening because of ChatGPT. Right? So there's two ways to look at ChatGPT as a user, but I think as engineers, what we look at is how does it work? What happens inside? You could have a 3-hour presentation on that, so I won't go into that, but I give an idea because I use ChatGPT as an example as to why you need new designs. And I'm going to use it as an example as to why it is needed. So in ChatGPT, you need to look at those GPT part. That's what is AI is about. That gives a lot of information about what is AI. So the first part is generative. Sir talked about generative AI, Gen AI, right? Wherein AI is used for recognition. So there's an image, you want to see if there's a cat or a dog in there, or it's in the camera of of an autopilot car, and the autopilot car has cameras which is capturing the scene, and you want to see if there's an obstruction based on which I need to take a decision. Right? So identification of the obstruction that's there on the road, how far is it, and so on, is what's the classical use of AI for many years now. But now, with ChatGPT and a lot of other applications which are there, you are generating new information. So, inputs come in, the AI system learns, and based on not learns, but based on the AI system's learning, the AI system finds out something and then takes an action or gives you some information, and that's what ChatGPT does. So any information it gives, it identifies, and it's able to give you a response. Not a plain response, and that's where the last letter T comes by. The word transformer comes by. It is not just very generic, but it's a little more than that. So 3 words there. G is for generative. Second word, again very important for this talk that we're having, is pre-training. Right? So it has to be trained. Right? If we are all going to work on VLSI, it is not that one day you just go and start working in VLSI, but you learn what are the concepts in VLSI, the different courses which are there, the different aspects of VLSI which is there, and based on that, you go into the industry and start working with it. And what you work in the industry is, again, not just what you learned out here, but based on your learning here, you have new learnings, you have new understandings, and you work with it. That's how we work. So every time when I get into the industry, I'll give you an example. When I was studying my master's, I learned the language C. But when I got into the industry, I worked in C++. I didn't work in C at all. I mean, I learned many years back. I don't know how many of you actually learn C these days, which is sad. It's a good language to learn. So I learned in C, but when I got out into the industry, I used those principles to learn a new language called C++, and then I worked with that. So that's what we do, and that's the pre-training part. So when you have an AI system, you're going to train it with some amount of information. Once the training is done is when the system is ready, and then you put it onto the market. So that's the pre-training phase, and this is a very critical phase, and this is where you probably are having new designs coming up. It is just to support this training phase that you need a lot of new designs. We'll go to why in a bit. And finally, transformers. This is also a very interesting concept that ChatGPT doesn't answer your question just based on what you're asking, but ChatGPT looks at the context. Right? What is your mood when you're asking it? Is it so you could just ask a question as a sentence and can it understand it? Right? So it will be a sentence that you're saying, but your tone will say that it's your tone or the way you arrange the words might say that it is not a sentence but it's a question. Second, the word it. So you have asked 3 lines, where the first line you will say referring to a car. Then in the last line you will say what is its price. So the it or the its in the last line is referring to the car from the first line. That's context. So the it has different meanings based on what you said earlier. That's what a transformer does. That's the transformer part where it remembers things. There's something called attention, right? Big word. And called attention, by which you remember what is happening. And second, the context which is there. You put these two and you're able to answer to that. And that's why ChatGPT is unique. Right? Google does the same thing, answer your questions, but ChatGPT understands your question and answers it accordingly. Okay. Now, all this is primarily working using these two words, neural networks. So inside all AI systems, you have a neural network. A neural network is the learning part of an AI system. And the neural network is based on what happens inside our head, right? Where we have neurons and the nerve system which is there. So this is AI or neural network is modeled. So the neural network is modeled on how our brain works. So it's got set up like that. That's a neural network. You see neural networks? All aware of neural networks? Yeah, I'm just going to spend a little bit of time on this because again, this is important to understand why we need to check. So simply put, this is a very simplistic diagram. It's not so simple. There are input layers where you give input values or information that you have or data that you have, and then it goes to a set of hidden layers. And ultimately, at the end of it, you get the output. Could be a single output or multiple outputs, which tell you, which identify something, or it's a response to what you want, and so on. So this is a neural network there, and you can see that there are two things important. So there are a number of nodes which are present. There are a number of nodes which are present. These nodes, in a manner, process the data that you give and give out the response. Right? They help you to reach the response. Second, you can see all nodes are connected to all nodes of the next layer. So every node in one layer is connected to every node in the next layer. Right? So which means that a data which comes in could go to all the nodes or a selective set of nodes or no node at all. Right? What makes it happen? We will get to that. So, this is the way it is designed. And just to take an example, if you get a part of it, how does it decide? If you give an input, how does it go? So if you take a set of nodes like that, there are two numbers that you see. One is inside the circle or the node, and second is on the arrows. Right? The ones inside the circle are called threshold. The ones on the circle, on the arrows are called weightage. So every node gives an output. The output is multiplied by the weightage, and that reaches the next node. And the next node decides whether to accept that input or not based on its threshold value. If I take the example of the 0.75 there, and you have a value coming from 1, which is above, the first one above, it is multiplied by 0.2, so it gets only 0.2, whereas the threshold is 0.75. So this value is not accepted, that input is not accepted. Right. So it is in general with this that it works. It's as simple as that in a way, but the complexity comes in that how do you reach that value 0.75, 0.8 and all those threshold values is a complex formula. Right? So what you need to remember in a neural network is that these numbers are not programmed in. We're used to programming in number, percentage is number, pass mark number, pass percentage number. We're not programming all these things, but this is computed by the AI program itself, or the neural network itself computes these values, and these values are generated there. And that happens during the pre-training phase. It happens during the pre-training phase where these numbers are getting computed by there, and that's the complexity that we have. So there is a mechanism which is not shown here, which is not called feedback. There is a feedback which happens. There can be a person during the training phase who gets involved and says, hey, this is not a correct output. So then what happens is that the AI program goes and computes, changes the computation a little bit, changes the values a little bit, and the values become different. This is an example which I thought was great, that there is a system which identifies a dog and a cat. It gives different values. It says it's a cat sometimes, it says it's a dog sometimes. The values get adjusted in such a manner that ultimately your output will come as a dog instead of a cat. And that's the training phase where it's giving you a lot of junk values, wrong responses, some right responses, and every time you tell the system that this is right or wrong, The system will correct some of the values, do some pre-computation, and automatically it sends it to the system. So it's not programmed in by me or you, but it takes care of us. So this is how the neural networks work. We're still not into why chips are needed. So what powers AI? How can you run an AI program? What is the underlying layer? Anyone?
Machine learning, deep learning,
Yeah, but where does it run?
process.
It runs on a chip. Right? It runs on a chip. It's a chip. AI is powered by a chip. Right? So obviously, we need to run or execute our AI program somewhere. It runs on a chip. But why can't it run on a GPU, not a GPU, but a CPU itself? General purpose processor or a CPU which is there. Right? Why does AI require a new chip design? So lots of work which is happening today, the trend that is there is that AI applications need their own chip. Right? And that's where a lot of work happens. Why? It's because of neural networks. Right? So again, before I go on to the answers to why a CPU can be used, let me just take an example. If you take a blue circle node, this blue circle node can give output to different of these nodes. So as a result of this blue circle node, the next layer, five nodes can be computing at the same time. And this is just a small example, it's a small case which is there, but this means that there's a high level of parallel processing which is required. We do parallel processing in our CPUs, but this requires a very high level of parallel processing. There are so many nodes which are computing parallel. Right? This is something which we need to remember. Right? So, as even a multi-core CPU does not do parallel processing. To some extent it does, but it's a sequential engine which is there. When you take a CPU or like your i7 or i5 or any of these Intel cores, you will still have only one instruction by another instruction happening sequentially, and it's not necessarily very parallel. Right? So then what happens is that when you're training an AI program or when you're even executing an AI program, it takes a long time because it's going to take one statement and then next statement and next statement, then change it comes back to that. So it takes a lot of time to do that. Another example is ChatGPT took 10,000 hours, where, I think about 40 odd days, with about 10,000 servers for it to get trained. We're talking about that amount of time which is there. It's got 175 million on parameters to be framed, those numbers to be framed. So it takes time for you to train it. But there's one architecture which is already present, which can take care of this amount of parallelism, which is your graphic processing units, which is your GPUs. And they can already work with it. So we have something which we can use it for an AI program. Now, why a GPU is good is because a GPU's ultimate output is your screen. How does your screen work? Each pixel in the screen. So you can't have a system wherein you have one pixel or one line which is drawn, and then the next line which comes by. But instead, how your system, GPU's output comes by is that one whole screen gets painted at the same time, which means each pixel will have a processing unit which is there, which is processing it. So in a way, I found this picture to be very interesting, that a CPU could have multiple computes which are there, but a GPU has a large number of parallel processing which happens, which is exactly what fits into what's needed for an AI program. Right? So the first time is developing architecture for chips. Right? But your question will be that a GPU is already present, which you can use. The graphic processing units are already available. Why can't I simply use that for an AI program? That doesn't work because of this picture, if I take it back, that the processing is very different. Some of those numbers are a result of very complex operations which are there. Second, an important concept which I don't put anywhere here is a feedback mechanism. So when there is a mistake, the value goes back in and changes happen in the formula and changes happen. So there's a feedback mechanism. And this means that you need to change the architecture. You use the base of a GPU, but change the architecture of each unit to take care of it. Second is that the data which is there in one node flows to a set of nodes, which means that you need to have good networking mechanism. We're working on a AI chip at Adrian, and there each computing node has it has a computing core, it has a memory, and it's also got a networking element by which the data flows from one node to another node, because the data has to flow and there can't be errors in it and so on. So there's a lot of work out there. I'll quickly run through the next one. I can see lots of impatience in the crowd, so I won't take too much of time. The next trend we're talking about, so this was something functional, in the sense that you have a functionality to achieve, which is AI to do that. The second is caused by, at the infrastructure level itself, where the size of the transistors are becoming smaller and smaller. Right? Moore's law said that the number of, all heard of Moore's law? Moore's law? Yes, no, maybe, possibly. Okay. So the Moore's law states that every 2 years, the number of transistors in the chip keeps increasing. Right? This is framed by Moore, who was one of the pioneers at Intel. And what he meant by that is that the size of the transistor almost halves every 2 years. 2 years. So which meant that the size of the transistor has fallen, and that's why your 7 nanometer, 10 nanometer, 100 nanometer comes back. So today it's at around 7 odd nanometers, which is there. It is almost as small as a silicon atom. It's reaching that place, and so it's becoming very challenging to build it. Right? What is the challenge that you face is that how you create chips is that there is you take a silicon wafer, you cover it with photoresistant material, and then you etch it out with light so that you can get the transistors. Now the etching out means that you need to have a sharp light which is there. So which means that earlier on they used to use normal light that you see here. Then they went to ultraviolet. Now there is an extreme ultraviolet range, which means really small wavelength of light is used to etch it out, like a sharp pencil. Right? And this means that the device that is used to etch out is very expensive, not everyone can afford. There are only 2 or 3 companies who can fabricate it. And that's why I think India is not going to look at the 7 nanometer yet. We're still in the 20s or something like that. We're not going to use a 7 nanometer because that equipment is simply too expensive. So, and also you can see that now in Apple's 2023 M2 Ultra dual chip, you have 134 billion transistors, which means that when I'm creating a chip, I need to ensure that 134 billion transistors are working as expected. So my verification of a new design, 80% of the time and the cost is spent on just verification. So it's becoming extremely expensive to do that. And we go back to Moore. Moore himself said that ultimately the chips are so small that it's going to be inefficient to just use them straight. You can use them in a modular manner. You can take the functionality and do that. And that's where you get to the concept of chiplets. So chiplets are they're a miniature integrated circuit. So which means that it's like a Lego block. So you have different Lego blocks. Each Lego block would be a GPU or a CPU or a memory unit and so on. And you have, you put it onto another IC, each of these blocks. So each of these blocks are independent, they're verified separately, and you just plug it in whichever you want to. Second, some of them might be 7 nanometers, some of them might be 100 nanometers and so on. You can mix and match different nanometers, and everything needed to be, in an SoC, everything has to be the same size. So, so you can mix and match, and you don't have to necessarily make your chip very expensive. Third, you could, you reuse it. Right? So this is an example. It's like a Lego block which is there. The second diagram out there, you see how it works. That each of the chiplet is a die by itself, and you insert it, and there is a die-to-die protocol which happens, or D2D protocol which happens, by which information is exchanged between each of this chiplet, and that's how it works. So as long as the functionality is there, as long as it's able to understand and work with it, that D2D protocol, you are able to use any kind of chiplet in there and create your own SoC. The final slide is that it's reusable intellectual property. So I don't have, in the case of, if I'm making an SoC, I need to have all the IPs which are there, and I need to verify it all over again. these are reusable, which means they are tested out. I don't have to test them out separately. It's a known good die. That's the last part. The die is good. You know it's good, so you don't have to work on it again. It's heterogeneous integration. So you have different providers providing a completely tested die, and you're not spending time and effort on it. So these are the two trends. First is AI-based chips architecture, the whole chip architecture change for AI. Second, more infrastructure required because of the smaller size of the transistors. You are able to get the chiplets by which you are able to manage your development. That's all I have. Thank you for listening.
Guys, if anybody has any doubts, you can ask. Anyone? Any doubts about the thought that Sir did? Not the doubts from outside. Anything? Anyone? Thank you, sir. Thank you for your valuable speech. Now, it's time to introduce our guest of honor. It is with great pleasure that I introduce to you tonight's guest of honor, Mr. Jeshul Samuel. With a formidable academic background, he earned his Bachelor of Engineering in Electronics and Telecommunications from the Lai Institute of Technology, Durg. Before delving into intricacies of VLSI design, obtaining an APGD from Vedant Semiconductor Complex Limited, Monali, and Master of Engineering from Karunya University, Coimbatore. Throughout his career, he has skills and expertise across various esteemed organizations, from his beginnings as an associate engineer at Slash Support India Private Limited, as pivotal roles at Wipro Technologies, HCL Technologies, Smartway Technologies, and Addison Company. His journey has led him to his current position as a principal engineer at Microchip Technology, INC, where his contributions continue to shape the landscape of technology and innovation. Please join me in welcoming Mr. Jeshul Samuel, a visionary leader and an exemplary professional whose dedication and passion have left an indelible mark on the realm of engineering and technology, to deliver a tech talk on the topic exploring the world of chip design, RTL to GDSIM. Sir, we may kindly welcome you to the dais.
It's a great pleasure and honor to be here. I thank the Dean, HOD Shirley ma'am, Karthik sir for inviting me, and HOD Mechanical Department, Computer Science Department, I was able to network. I congratulate the Advanced Technologies. I'm very happy that they have started here. I networked with them when I came here, and I'll give my full support for your success. So why am I happy for the Advanced? Why he's giving his all and telling what he's doing? First of all, I'd like to thank SRM. So you guys, everyone are you should be glad that you are part of the SRM plan. So why SRM is taking this initiative by having this conference? Why? Because they want to catch on to what's going on so that you guys should be benefited. So why are we here? That to us, you get to know what's going on in the present scenario and how you can come up or you can upskill yourself, come up with the field, right? So it's not, I understand like a lot of things going up, but try to do, catch up what you can do, okay? So motivation of this presentation, why I'm here? Anyone interested why I'm here? So I was saying like, interested or you want to just finish it off first? Okay. So my aim of this is what you should do to get into the field, in the BLSS field, right? So I'm here to give my insight. What can we do? Okay. There are different fields from architect to engineering. Okay, this is a big thing, right? Typical design flow. So what is the specification, chip level? So Sir mentioned some of the aspects what he is into, right? So first of all, specification. For example, you have a mobile phone that has what is the processor in that, what is the RAM in that. You are into that, okay? So similarly, specification, chip level specification, macro level specification. And I have given different level of coding in here. So these are the different fields where we can get jobs. So for example, you want to get into a Qualcomm, you may be working as a lead, just doing lead. Or you may be working as a synthesis, manual synthesis. So that's what talks about this flow here. I have around 17 years of experience in the industry, and my primary experience is in the front-end verification. So I do module level, chip level, and right now I'm into project management. I lead A0 projects. What do you mean by A0 project is that you start a chip from scratch and then give it to closure and RTT. RTT means reads to production. So what do you mean by GDS2 is you give the specification, you code the RTL, you give it back to the GDS2, and then it's fabbing means you are giving it to the fab. And from the fab out, based on the technology. So Sir mentioned Moore's law, right? So right now we have gone further till 2 nanometer also. I think some 1 point something is working on. You can Google it, what is Moore's law. So based on the technology, you are still going further. And why is that there is so much war cry on Taiwan? Should fab be in Taiwan or should be in US? Why is India also getting into it? You know, anyone know about the fab war? You have any idea about that? Can I know the audience who are all from the final year or anyone from the third year? You are from the third year? Okay, you have studied real estate? Okay. Okay. What else you have studied? You have gone through the ethics law? Okay, so few things. So when here, right, so you are all coming back-handed, you should have some notes to gist of important points, right? So it's like we are coming here so that we are spending time here so that you are benefited. SRM is dedicating this time so that you are benefited. So make sure that you make use of this opportunity, okay? So the different colors here are the different fields. So typically, I would say that in a nutshell, there are 3 fields, okay? Front end, mid end, back end. I mentioned I'm in the front end guy, okay? So I do the verification stuff. And when you talk about the technology, 4 nanometer, 7 nanometer, that comes in the back end. In between, there's a mid end also. So if you see the synthesis, scan insertion, logic formality, so these are all the mid end. So how directly you won't be able to go into that, right? So in order to go into that, what do you have to do? You have to have your basics strong. I'll just go about what are the product companies there. This is not the only thing. Whatever I could do, put it in this slide, I have put it. So do you know any companies here? Your mobile is having which brand of code? CPU. Okay. And I'm from a company called Microchip that deals with microcontrollers. So anyone knows what is the difference between a microcontroller and a microprocessor? So these are the things you should be working on, okay? So before, so below if you see Cadence, Synopsys, Siemens, are you using any Cadence books here? Or Meta Graphics? It's Siemens now. No? VLSI lab, anyone having VLSI lab taken? What are the, can anyone tell what you are doing in that lab? Okay. So this is a list of the product-based companies, and also there is service-based companies. So what is the difference between product-based and service-based? Can anyone tell? I work in both service and product-based companies, so you know what? So product-based companies are companies, they have their own product, and they have we'll be working for that product. And service-based companies are like we'll be working for, say for Qualcomm will be outsourcing for some verification task, or from mid-end task to run the synthesis, we'll be doing that. So what is the difference between that, which is better? For now, as a fresher, you can join anywhere. Okay, so it's not. This is the right time. You have an opportunity. So the companies, it's very easy to go via campus placement, right? So your aim should be, as students, to come and get selected when you are in college. Make use of the opportunities. How many companies are coming? Do well, clear your subjects, have your basics properly, get into a job. That's what I would say. But you should be knowing what all are the companies present in India about the VLSI. I mentioned only the VLSI. Yeah. So companies in Chennai. Why I'm glad about Edvion is that as professionals, we are glad when there is there is upgradation going in the industry in the same field. So I'm happy for Edvion, and likewise I want many other companies to come in Chennai. So it's a mutual understanding, and that's what we want. So Qualcomm is that, Mobile is that, P-Semi. P-Semi is a Maratha company, not many will be knowing about it. It's a good company in Chennai. Okay, and HCL is there, Edvion, Tata Patents, anybody knows Tata Patents? These with different projects. It's also in Chennai. Anisha is a new company, ABB is a product company, and Microchip. So, while I'm talking about this, what are the prerequisites for going into a company like that? What you need? You need to have strong digital design basics. So, have everyone studied digital design in your curriculum? So, can any of you come and explain me what is the difference between a flip-flop and a latch? So this is the first question I asked in my interview. You can't go to ChatGPT and check what is flip-flops and latch. Latch. You should be knowing it thoroughly. This is something like, it's a constraint. You should be able to add constraint to the AI tool. So that is your mind. So you should brush up your basics. So other HDL languages like Verilog, System Verilog. So any of you have learned HDL Verilog here? Anybody know? Verilog, you know? So Verilog, so first question I'll ask is, what is the difference between blocking and non-blocking? You know that? So these are the questions you should be strong in it when you are venturing into it. So as a fresher, you should be knowing the basics. Okay? Good debugging skills are required, knowledge to the latest EDA tools. So I was asking what are the tools used in your lab? Xilinx. So Xilinx is part of which company now? So Xilinx is bought by a company called AMD. Okay, you should be aware of what's happening, right? Okay, Unix knowledge. Anybody has Linux in their PC? Or everyone using Windows, or anyone has Unix Ubuntu? Any gamer here? Okay. So Linux is very important. You should be knowing how to crack it. I want to search for error in all the logs. There are millions of codes. You need to know how to find command. What is a grep command? These are the basic requisites. And a Git repository. Are you using any Git repository? Part of GitHub or anything? So this is another thing you will have to add it. Keep planning attitude, open to LAN, unLAN, reLAN. So this is something, there will be many new technology coming in. You don't know which thing to learn. So first of all, keep your basics right, and then you go into a company, you learn what is, there will be a protocol. For example, maybe having an AXI protocol. Anybody knows what is the AXI protocol? AHB? Okay. So recommended resources. So this same topic, I didn't go through the entire thing. The RTL to GTS 2, that's a course in NPTEL. I would recommend everyone to, that's taken by IIT professor, and it's a 12-week course, I believe. So I just mentioned that these are the many places where you can get the job based on your expertise, okay? So tutorials where the ED vendor. So when you have, I mentioned you have a Linux environment. So if you have a Cadence or Siemens or Synopsys, they have a bin directory with the examples. They have a lot of tutorials. So you should be able to make use of those examples. IEEE, you have access to IEEE, you go through the various documents to ensure. This link I have mentioned about the ecosystem, where you will know what is happening on the VLS side. You can get this PPT from Karthik sir, or you can ping me in LinkedIn for any updates. So I have mentioned this. Can anybody tell me what is the course code here? I got it from Google. You know anything? This is your own subject, right? So you should get well versed in whatever is there in that. Before going to what, you should be able to define what is a flip-flop, what is a latch. You know, clock divided by 2 circuit, you should be able to draw it. So in Hindi, anybody from North India here? You know what is the Lakshya, one of the favorite dialogue. घास काटो तो अच्छी तरह से घास काटना. Can anybody translate in Tamil? So ideally, you should do whatever you are doing it properly. You know, do it properly. So I would encourage you to have this properly. Like there is a Maurice book, Charles Rouse, L. Floyd. Do you have got Xerox for this, or do you have an original book for this? You have got the book or Xerox. These are wonderful books. You should be liking this. If you want to have a career in PLSI, this is the basic. I would also like to add one more. John Walker-Lee, Digital Design Logic by John Walker-Lee. So if you have in your library, you can request in your library. So these are the things you should go. I just completed. I won't take much time. So this is your onus on you now. You have to ask me a question. What do you want to know? Any questions you have?
Sir. Sir, here, over here. Sir, as a fresher, what knowledge we need to know to get into a core industry?
So I mentioned the theory, right? So do you know Beyond, they have conducted a walking recently. I had recommended few of the interns to apply for it. So LinkedIn is one place where you can connect, right? So in our company, we do have intern opportunities. I have recommended to HOD man. So hopefully that works out. Let's see. So in our company, we go to internship and they are doing the campus placement. Right now they are, so there are companies where they do internship like Synopsys, Intel. Now at Beyond, they said they are having regular walking. So be aware of what's going on. So as I mentioned, like I'm very happy. So you want to stay in Chennai or you want to move to Bangalore?
I want to move to Bangalore or some other state.
Okay. So there are a lot of opportunities in Bangalore. So one question I will say is, so when you go to an interview, if you, what is your aim or what is your goal for the next 5 years? So what will you say?
So currently I'm learning Cadence tools and EDA tools. So I think I'll try to get into a core company like Cadence or Synopsys. So that's what my aim is.
So when you say that like to Beyond in the walking, will you get hired?
I try.
No, what I'm trying to say here is, so say in the interview, they ask you what is your aim or for the next 5 years, you say I want to go to the US or want to go to a core company, that's a big no-no. That's my 2 cents for you guys. Don't tell them that I want to go to US and learn MS there. You won't be selected. Not for the sake of. So we are not only looking for best minds, but also some attitude. Like you should be having continuous learning attitude. You should be having a stable. We want stability for at least 3 years, not less than that, right? We are teaching you all this stuff, right? So we are teaching you, and then you go. You say I want to go to a core company. That's a big no-no. So I would say have an open mindset. Not everyone gets luck to go to the product-based company, right? Initially, at least try to increase your skills. Be very strong in digital. If you want to go to analog, so that's not my core area here. Learn analog stuff. You should be at least good in the CMOS circuit. You should be able to know what is an ADC, the conversion, right? So if you want to go to the front end, these are the prerequisites I would say. Verilog, system Verilog, everything can be learned. You have LRM, you can search it in the IEEE. You have a lot of NPTEL courses are there. NPTEL is very good. So you can do there is marks there. You can see a lot of guys who are getting good marks in that. So you can enhance your skill set in that. So that is one thing. Any other questions? So I'm here. You can use me. You can ask me questions. It's up to you. I see that you nobody got any books or notebooks. You are just going through the motions, huh? I was also like that in 2004. But then, so my aim during my engineering was just to have a RX 100 bike, you know. That's all. So what is your aim now? What is your Lakshya? You know, that is a very good movie. Anything else? Some 2 cents? You are always on your own, okay? Nobody will be there to push you. Right now, SRM is trying to push you guys. Get 2 cents out of me to sir, and you know, that stuff. So it's up to you what you take. So घास काटो तो अच्छी तरह से घास काटना, you know. Thank you.
Thank you so much, sir, for your wonderful talk. Guys, within few minutes, we are moving on to a wonderful panel discussion with the 4 panel members and 1 moderator about the topic addressing the skill gap in the semiconductor industry. Let's head on into a wonderful session, a panel discussion on the topic addressing the skill gap in the semiconductor industry, and we take immense pleasure in welcoming our esteemed panel members onto the stage. So, it's time for the felicitation. I now request our HOD ma'am to felicitate our moderator, Dr. K. Swaminathan, founder and CEO, Silk Innova Technologies Private Limited. I now request Karthik sir to felicitate Mr. Hariharan VS, Vice President HR at Beyond Technologies. I now request our HOD ma'am to felicitate Mr. Sriram Tangarasu, Senior Branding Specialist, Mobivale Inc. I now request Karthik sir to felicitate Mr. Vignesh Damodaran, Senior Verification Engineer, Qualcomm. Over to the panel members for the eagerly awaited panel discussion. Thank you.
Very good morning. Yes, everyone. Today is one of the special day. There are two initiatives this year, even last year also. One is ISM, Indian Semiconductor Mission. And in January in Tamil Nadu government announced Tamil Nadu Semiconductor Policy 2024. So there are a lot of claims. One thing is very noticeable by the student. They are planning for 2 lakhs semiconductor job within 2030. 2 lakhs. Unfortunately, if you take in Chennai, how many VLSI engineers are there? I hope it is less than 3 degrees. And in Tamil Nadu, there are 555 colleges, around 1,20,000 circuit branch students, more than they are passed out. Less than 1% of student only placed in a semiconductor companies. It could be VLSI engineer or embedded system engineer. And there is a wide gap between industry and academia. So with this esteemed panelists, we will discuss various job opportunities, skill sets, various innovation happening in various industry. Before that, we must be proud of to be an engineer for various reasons. We'll tell some three reasons. Have you heard of fake doctor arrested, fake advocate arrested, fake nurse was arrested? Have you ever heard fake engineer was arrested? We never hear because the problem is engineering is not simply science. You need to do the things, innovate, build the things. That's why the infrastructure, communication, healthcare, automotive industry, everything is involved. Another thing is, in 2010 onwards, the IAS passed out, who all cracked the UPSC examination. More than 50% of students are having engineering background. Why it's so? So we have that kind of resilience. We have around 45 papers, 240 cycle tests, few arrears, and a lot of voice. So you make this degree as strong enough to face any kind of challenges. And on average, every student, engineering student, they attended 240 examinations. That is more than sufficient. We have a question. You are writing around 240 examination in your field of study. And if you come for the placement, why you are looking for software job than certificate? You ask yourself, I'm a student, I studied 4 years, around 48 subjects, around 240 examinations, there are labs and viva-wise. Finally, I prepare for aptitude a month and some software languages for 1 or 2 months. So I'll end up with some software. For that job, have you used any of your subject knowledge? So that is a question to ask each and every circuit branch students. Especially, there are a lot of pride to be an engineer. More pride to become a circuit branch engineer, to be electrical or electronics. We are seeing the world as a very small. Even who knows in future they will convert human being as a bits and bytes, they will say. So there are a lot of technology advancement. If you take automotive industry also, why the car prices are so high? Not because of the mechanical parts. A lot of electronics, a lot of sensors, a lot of control. So that's why this is one of very good field to shine. Just try to focus on VLSI. And I delighted to be here in SRM Institute. They identify this area. This is one of the emerging field, and they need to make the awareness to the students to cultivate them to become a VLSI engineer. With this notes, I start with our panelist member. So Karthik Nagapan, I met you sir in 2010 at L&T building in front of Jagdish. Okay. So he is the right person to tell few questions. He has a decade of experience. He completed his degree in US. I think it was in electrical, it was in VLSI in Illinois. And he has around 3 decades of VLSI experience. I know some of his colleagues and I know well about his leadership. Sir, I have clarity. Why circuit branch students will focus for semiconductor job? Why not software?
I think it's a very valid question which is being asked in every institution I'm going, and I'm for the last 6 years, right, starting from 2017, have been motivating students, why not focus on circuit degrees. Sir itself, Karthikeyan sir itself has sent so many engineers to me for internship. Finally, they end up taking software jobs and not circuit jobs. Why? We all understand that there are infinite number of opportunities in software, but it is very less in circuit branches. But that trend is changing. What it was in 2017 is not the situation today. India is also getting into manufacturing, and there are a lot of OSATs which are being opened in Krishnagiri and Hosur. There is a lot of need for ECE engineers to go and run these test engineering plants as well as the fabs which are being set up. So in the next 10 years, the demand for ECE engineers is going to be high. And it is also rewarding for engineers if they are long term in this business. Then if you see and especially what I see is very less intake of students from Tamil Nadu for circuit degree. But that's not the case in Andhra and Telangana. They want to get into core jobs and they're getting into core jobs. It takes some time, but they're ready to spend that time and get into it. Because the remuneration for a silicon engineer or a test engineer is much more higher than a software engineer, and a software engineer salary stagnates after a certain point of time. For example, let me take my case itself. Okay, in 1997, in my class, there were about 35 electronics and instrumentation engineers, out of which 3 only got into VLSI and 32 got into software. Okay. Today, I am a vice president at Dassault, and there are 2 other people in US. One is a vice president at Texas Instruments, and there is one more who is running his own company, Silicon Design Company. So it takes time, but it is fruitful and rewarding also. So I don't think there is less opportunities now for design or manufacturing or test in India. So I think that is going to be the future. If you want to go into a software job, go into CS in the first year itself. Don't take EC. If you take EC, try. I'm not saying you should not go into software job. Just try to get into core at least. Or you can even pursue a MTech in VLSI design course. It is very fruitful. It is very rewarding. So that is my.
Yes, very valuable input. I think I had seen during my PhD in NIT, I think only Suresh and Parthivan from Paul, these 2 guys are from Tamil Nadu. Remaining around 60 members from majority of people Andhra, Telangana, and it doesn't matter. I appreciate them, they have the awareness. In Tamil Nadu, Chennai became a source capital. We are looking for like software. I have another question. You wait for 21 years just to spend 6-4 months to learn the things, to land up the job in semiconductor industry. That should be very meaningful for your degree, EC, or any circuit branch. So thank you, sir. Then Sriram is alumnus of your institute. He completed his MBA in 2017. He is frequently interacting various college students and various professors. Sriram, I have a question for you. You interact a lot of students. What are the primary challenges they are facing to enter into the VLSI?
Good evening to all. So I mean good afternoon to all. So the primary challenges what I see in most colleges, students is that they lack few skills. They know they have the awareness that they want to go to a core company, but they don't know exactly where to start. And there are certain requirements in semiconductors. So the college academics and the job opportunity, there is a skill gap. So students need to understand what they need to learn. As Sir said, we are EC engineers, EC, EEE, even CSE, UCO. I have seen a lot of students with EEE background coming and joining in EC, VLSI course actually. The thing is that the interest on VLSI field that matters, and you need to understand that there is a huge market in the future for VLSI engineers. You need to upskill your basics first. From digital electronics, Verilog, system Verilog. You need to take one step at a time. You can do offline courses, online courses once in your final years, or small projects, even mini projects that would help you understand what is the market demand and how to be a verification engineer or any engineer. First thing is that you have to an attitude towards your passion. If that is not there, you need to grow a lot more, because it's very challenging. Because once you complete your degree, there are almost like 10,000 more candidates who are well trained than you. Then the competition starts. So that's why it will be too late, but it's not too late to start also. So take one step at a time, but understand that you are an engineer with a easy background and you have a future. By the end of your career, you should be like you should come to a place where people will understand that this guy has done miles before your batchmates could have done. So that's what I'm telling. That's all.
Thank you. We underline two things: attitude, and you need to be passionate about to become a VLS engineer. That was very key. Even last year, I recruited around 15 members in 7 colleges, Tier 2, 3, very rural. National College at Pulpati and MEFCO, Sarana and Trichy, like that. I asked you 2 questions. Just to form a full ladder using 2 off order. None of them answered. The problem is they already completed important subject within 3rd and 4th semester. In the final year, we are dig the basic, like basic electronics or digital electronics. And I asked one more question. I have a flower latch. I input the same signal. What would be the output? You draw the output. But students are ready to write a page about the difference between latch and flip-flop. But they didn't understand what is the actual meaning. So the thing is, we have 45 subjects. Need not to be learn all the subjects thoroughly. Only few subjects. With this, I will go with Vignesh. He is also alumnus of SRM, and I have seen his LinkedIn profile. He crafted well his professionally. Now he is a verification engineer at Qualcomm. So, Vignesh, you already studied 45 subjects. Every engineer's do. That too, PhD, other MTech, around 67 subjects. So, how many subjects are really needed to get a job in VLSI? So, whether your curriculum somehow help you to give your advice to the student, what are the subjects they need to focus to cracking in VLSI?
First of all, I would like to thank Karthik sir and Dinesh sir for having invited me here for this SRM conference. So it's very privileged to me. So from being a student to sit here among other industry experts and talking about the semiconductor industry, it's a very great honor to me. Now I'm coming to your question. So the subjects students need to focus on. So I think digital design is very, very important. The digital electronics is very important. And so analog